What is up, YouTube? Fallen Psycho 82 here, coming at you with a video to start off my segment on Yu-Gi-Oh! Statistics and probabilities. So, a lot of you may know that there are certain odds that you'll draw certain cards at certain times, and I do believe it really helps in deck building and in playing the game. So, we're going to start out with this basic formula. Well, not entirely basic, but X, C, Y. X and Y are variables here representing two different numbers. C is a mathematical operation similar to plus, minus, multiply, divide. So what XCY equals is X factorial divided by Y factorial times X minus Y factorial. What factorial is it multiplies everything from that to 1. So if it was, say, 5 factorial, it would be 5 times 4 times 3 times 2 times 1. And it gets really big really fast. So for our example problem to demonstrate this, we'll do 9, choose 5. So this will equal 9 factorial divided by 5 factorial times 9 minus 5 factorial. So this may not make a lot of sense to a lot of you. Don't worry, it will be explained. So we're going to start off by opening Google, because Google makes an excellent calculator. So now what we're going to do is we're going to translate this. So to simplify it down to begin with, we'll just simplify it to 9 factorial divided by 5 factorial times 4 factorial. If we'd done 9 choose 4, it would be the same equation, because it would be, hold on, let me do this. 9 choose 4 would equal 9 divided by 4 times 9 minus 4 factorial, which would equal 9 divided by 4 times 5. And those two equations are equal. So if you do the reverse, like 9 choose 6 and 9 choose 3 are equal, the reverse is always equal. So we're just going to solve for this for now. So what we could do now is go take away the 5 factorial from the 9 factorial. So what this means is it basically becomes 9 times 8 times 7 times 6. So we'll put that in. And this is this is divided by 4 factorial. 4 factorial is a much easier number to compute. It's going to be 9 times 8 times 7 times 6 divided by 1 times 2 is 2 times 3 is 6 times 4 is 24. So now we put this into our calculator, and we get this, and we divide it by 24, and that's the amount of different ways in that you can get 5 different things out of 9 things. So in this case, it would be, say we have 9 cards here, and we want to choose 5 of them. You can get 126 different combinations, and that's how you'll compute that. So for our purposes, we want to know what's the probability that we'll open a card that we play 3 of. So to start, we need to know how many different hands we have in a deck. So this is going to be a 40-6 problem in a 40 card deck, because you're getting 6 different cards. If we play 1 upstart, it becomes 39 choose 6. If we play 2 upstart, it becomes 38 choose 6. And if we play 3 upstart, it becomes 37 choose 6. And we are going to now compute this out. It's going to be 40 bang divided by 6. This is a slightly tedious part, but we get the math done. This is going to equal times 34, so it's going to be 40 times 39 times 38 times 37 times 36 times 35, because the 40 minus 6 comes to 34, and we remove that. So now we know 4 factorial is 24, so we multiply it by 5 and get 120, multiply that by 6 and get 720. So it's all going to be divided by 720. Now we're going to copy and paste this into our wonderful calculator, Google. And we get this number. Actually, it comes out nicely, 3838380. And that's the amount of different hands you get in a 40 card deck. 39, we're going to assume it's going to be slightly less, but we're going to do the math out anyway. You can see where the math comes slightly less, because it's going to come out to 33 instead of 34. So the numbers are just all slightly smaller. So it's going to be 39 times 38 times 37 times 36 times 35. Oh, times 34. And we divide by 720 again. Then we copy and paste this into our calculator. It comes out into another interesting number, 3262623. 3262623. And that's the amount of hands you can get in that deck. So I actually created a formula for how to compute these faster instead of doing it out over and over. You'll notice the difference between these two equations is we removed the 40 and added the 34. So if we want to write this out simpler, it would be x minus 1. So x being the 40, if we had x minus 1, it would equal 39. Choose y, that's still a 6, equals x, choose y, divided by x, then multiplied by x minus y. And this is going to come out exactly the same. So if we want to do this faster, we can now take this and put that in, and we divide by 39 since that's our x, and then we multiply this by 33, and we come out with this for the next one. I can prove this works now by, oh, that's not good. Let's just type in 2760681. If I want to do this out to prove it, I can go 38 divided by 6 times 38 minus 6 equals, that's going to be 32, so we have 38 times 37 times 36 times 35 times 34 times 33 divided by 720. Copy and paste this into our calculator, and it comes out exactly the same. So that's our quick proof, and so instead of doing it out for this, we can just take this number, divide it by 38, multiply it by 32. So we divide by 38, multiply by 32, and we get 2324784. And those are the amount of hands you can get in each of these decks. So as you can see, the number of hands you get drastically decreases when you put in 3 upstarts. I do not know how much this will help given the different decks, but I know in a lot of decks you will want to minimize your hands, such as in a deck like 3X's Fire Fist, like I uploaded yesterday. You'll oftentimes want to minimize the cards in your deck so as to draw your combo pieces faster. This is why I opted to play Upstart at the regionals that I topped in March. So, barring that, we now have the number of hands. So now what we want to do is calculate how likely it is to get a card we play 3 of. So here's DN. We're going to let that load for a second. Oh, DN may have crashed. Assuming DN crashed, let's say we really want to draw Death Lakuta. We're playing Pac-Man or something. So what we want to do is calculate the odds of 3 choose 1, because this is the odds of getting one of a card we play 3 of. Then we're going to multiply it by 37, choose 5. This is the amount of cards left in deck after we cancel out this. This is the amount of cards left in hand after we take out 1 to be the card we play 3 of. And we divide it all by 40, choose 6, because that's the total. So it's going to come out to 3, choose 1. I can simplify this down and just tell you right out it's 3. How many ways can you get one thing when you have 3 things? 3. So we have 3 times 37 divided by 5 times 37 minus 5 Oh, forgot to save this. Whatever. So we now have this, and this is going to be divided by 3838380. Now we're going to multiply this out. It's going to come to 3 times 37 times 36 times 35 times 34. Should be about right. If we cancel out 33 from that. Yeah. So this is the number we get. That doesn't seem exactly right, though. Oh, that's because there's also 32. I did some math wrong. Anyways, then we divide by 3838380. Oh, not to mention, there's also, this is divided by 120. And we divide the whole thing by this. So we put this into our calculator. And this is the percent chance that we get one of a card we play 3. We're going to simplify this to 33%. And that's the odds that you draw a card, one version of a card that you play 3 of. So now in order to get the total that we play, that we get at least one, we have to do for 3 choose 2. So since that's the parallel of 3 choose 1, it's going to be the same, it's going to be 3. So we have this times 37 choose 4, because we took 2 cards out of our hands this time, divided by 40 choose 6. It's going to be times 3 times 37 divided by 4 times 37 minus 4. Forgot the parenthesis right there. And it's all going to be divided by 3838380. And it's going to come out to 3 times 37 times 36 times 35 times 34 divided by 24 divided by 3838380. If we plug this into our marvelous calculator, we come out with 0.05. So there's a 5% chance you get 2 of a card you play 3 of, roughly. Yeah. Equals 5%. Now, if we go to 3, choose 3, we have to multiply it by 37, choose 3, divided by 40, choose 6. Which equals, there's actually one way to get 3 of 3. So we have 1 times 37 divided by 3 times 37 minus 3 divided by 38380. This is going to equal 1 times 37 times 36 times 35 divided by 6 divided by 3838380. So as you can imagine, this is going to come out to a much smaller number than the others have been. 0.002%. So roughly it's going to be 0.002, which is less than 1%. So all in all, the chance that in a 40 card deck we open a card, at least one of a card we play 3 of, is roughly 38 to 39%. So taking that into account, it's going to get smaller if we shrink the cards in the deck, and I'll be covering that next week on the next segment of Statistics Sunday. So I hope you guys enjoyed the video. Like, comment, subscribe, and I will see you later. Peace out.